Today our topic is production welding of steel castings. Welding is a fundamental process in steel manufacturing and is used both in manufacturing the steel and then assembling the steel into usable shapes. And so welding is an ordinary and fundamental process in steel manufacturing. I thought it would be interesting. This is a book I have from 1922 from John Howe Hall, called The Steel Foundry, written in 1922, and it's got a section on welding where it says blowholes, shrink holes, which not many years ago would have made it necessary to scrap a casting, are today welded by means of oxyacetylene or gas torch or electric arc. This actually is interesting because in 1920 is when they first started using flux-coated wire. So this is brand new. Further in that section, it says, in the hands of a skillful welder, shrink, sand holes, small scabs, etc., are repaired in such a manner as to not only remedy the defect, but produce a casting nearly, if not quite, as serviceable as though it had been sound in the first place. This is no longer accurate. Actually, welding can improve the properties. We use welding in certain locations to give us properties we don't get in the casting itself. In wear products, for example, we'll put wear materials on high wear surfaces that are harder and give us better performance. And so welding is just another tool in our toolbox to maximize the value and benefit of the steel casting process. Historically, one of the things that was done 50 years ago and certainly made against the specifications even more than 50 years ago was to use some kind of filler when I had a casting that had something on the surface that was unacceptable, some porosity or some rough surface, and use Bondo or the JB Weld to fill that hole up. I used to hear from lots of people that the word sincerity in Latin was really without wax, and because of that, it meant that the casting was made perfectly sound because I hadn't used wax to fill up the holes. So being the kind of nerdy guy I am, I actually went out and looked up to see whether or not that was an accurate derivation of the word sincerity. And the Oxford English Dictionary says, no, that's not correct. There's no possibility, no probability that the old explanation without wax is correct. And so that's not correct. But this does point out something that's fundamental. One of the main reasons that welding is an issue in steel casting production is because there are suppliers who lack integrity, and they use welding to provide castings that look as though they're in compliance, when in reality they haven't complied with the specification or with the welding requirements embedded in the specification. I know of a case where a developing country filled up porosity with steel shot and welded a plate over it, and then shot blasted it so that it would pass radiography, but certainly was not a sound casting. And so the fundamental problem with welding in steel castings is I can weld it and you can't detect the weld, and therefore you're dependent on my integrity. I know of another example. One of the things with the latest valve specifications, they want you to make a first article and forbid welding in order to qualify your first article. So I asked a gentleman who was developing that standard why, and the story he told me was that they had purchased some valves, again, from a developing country, and when the valves came in, they noticed some problems with it. So when they began to investigate, the valves, which required weld maps, had no welds indicated, but there were large welds on the valve, and the welds were made out of a different material than the valve itself, a non-compliant material. And I told him, I said, there's no specification that's going to keep a supplier from lying to you. So the real challenge of welding is to make sure that that process is managed with integrity so that you're confident that the welds actually perform their function and create the casting that complies with all the requirements. Unfortunately, we use the language repair weld as though welding is an unusual or unexpected event. In a steel foundry, my welders are on the payroll. They show up every day. I don't hire a welder because one of my castings broke. I have welders because I need to meet all of my customers' requirements. And when the casting doesn't meet all the requirements, I can use welding to make a compliant casting. So this is what a repair weld is. This cracked and I welded it up. Another use of the word repair welding, and this goes back to the 1920s, is if I weld it and it cracks, I have to grind out that weld and repair it. So if I look at the AWS D1.1 standard, there's a section 5.26 repairs where it identifies the requirements for repairing a weld. And you can see that in this video. This is somebody getting qualified and welding a pipeline to do a repair weld. So he's actually grinding out the non-compliant weld that had slag and failed to meet the ultrasonic requirements. And then he's going to have to re-weld that section. And then that section has to comply with the requirements. So repair welding originally really meant either fixing something that broke, a crack or a failure, or it meant replacing a weld that had failed. We adopted it as steel castings because in 1925, that was really hotshot new technology. So using repair welding showed we were up to the latest technology. But in today's world, when we say repair welding, it gives the impression that we somehow failed to make the casting correctly, and that's just not correct. We make the castings as well as we can because we don't want to have any welding on it because that costs us more money, but the casting process is such we don't have full control over all of the events that occur, and we want to make sure that our castings meet all of your requirements. So just like I may have to reheat treat something or do some additional machining, if I fail to meet the requirements the first time, I use welding to meet the requirements. Oftentimes I'll even plan to do welding because there are sections of the casting that I know can't be made economically to meet the requirements. And so welding of a steel casting is an expected and ordinary part of the steel casting production. Most steel castings are ordered to ASTM grades. The ASTM grades all have the common requirements grouped into two different specifications. One of the specifications is A781, and that's for common and general industrial use. The other is A703, which is for pressure containing or more critical components. But in both cases, they specify repair by welding, and they reference A488. And so we, in steel castings, if you order to ASTM, the foundry is permitted to use welding to make sure they achieve all of your requirements. But they can't just weld willy-nilly with any guy that they hire off the street. They have to comply with ASTM A488. And so one of the problems that we have that is always kind of a challenge for us is we'll make something like this flange and sell it to you, and you'll weld it to a pipe, and yet you won't allow us to do welding on the flange in order to meet your quality requirements. And it's going to be welded into service. And so as far as we know, as producers, if you can weld it into service, then we should be able to weld it to meet your quality requirements. We actually have to, under each specification, this is ASTM A216, which is plain carbon steel, WCB, most common alloy we make. And it says that if I repair it, I have to use ASTM A488. It says I have to inspect it to the same quality standards, and it defines how big of a weld I can make without permission and what inspection I have to do. So welding in the steel casting industry by all the commercial standards is heavily regulated. ISO, we were successful at changing this language of repair by welding to production welding. And so we're working with ASTM to change the language. Repair welding is after I ship the casting to the customer. If anything needs to be done after that, that's repair welding. Production welding is any welding I do in my shop to meet your requirements. We even have it here. One of the challenges we face is in the US, we normally use 20% of the wall thickness for a major weld. The Europeans use 40% of the wall thickness. That's not as big a deal as it might seem because both of us, if it's deeper than an inch, it's a major weld. So this is ASTM A488, and you can see that within the scope, it requires a record of the Weld Procedure Qualification Test, a PQR. The welder operator performance qualification test, and the weld procedure specification. All of these are required, and all of them are available to the purchaser. So if you want to know if the foundry is capable of making your parts and you're concerned about them using welding as part of their ordinary production practice, you have every right to ask for and receive copies of, or at least examine, their welding qualification. This is the recommended form for the weld procedure qualification, the PQR. This is the recommended form for the qualification of the welder. This is the recommended form for the weld procedure specification, all in ASTM 488. We not only qualify ourselves to ASTM 488, but we also can qualify to ASME Section 9, to the boiler and pressure vessel code. So if I'm qualified to Section 9, that counts for ASTM 488. But I have to prove that I have a weld procedure that meets the mechanical property requirements, and that my welders who's actually doing the job are capable of meeting the quality standards. Now, one of the other terms other than repair that's really misused as a misnomer is this term upgrading. Upgrading really is a valve term only, and it means that I've made a standard valve to B16 and it's sitting on the shelf, and all of a sudden my customer wants to requalify that valve as a special valve that has additional NDT requirements. So I take that commercial valve that's in a box sitting on the shelf, I take the casting out of it, I x-ray it, I find that there are NDT indications that are unacceptable under the special valve specification, and so I may have to remove non-compliant material and use welding to meet the special valve requirements. So upgrading is not an ordinary finishing operation to take a bad casting and make it good. It is and production welding is not upgrading. Upgrading is taking a product that's already been made to a lower NDT standard, imposing a higher NDT standard, and therefore I have to do additional inspection and I may have to do additional finishing work in order to qualify it. Here's some additional thoughts for you. Under ASTM 488 or ASME Section 9, the procedure qualification can be carried out either on the cast or the mill material, the wrought material, or the forged material, because under the US or North American system, these materials that are in the same subgroup are considered the same in terms of welding. In ASTM and ASME, I can approve all the grades in a group when any one in the group is approved. Now in ISO, they require that I have the most highly alloyed, the most difficult to be welded to qualify all of the members of a group, whereas ASME and ASTM allow me to use any grade in that group to qualify. ASTM 703 and 781 have supplementary requirements for examination. They also have supplementary requirements if you want a weld map. You can also define, ASTM used to have definitions for major weld. We dropped that, and so it's up to you as a customer to define what a major weld is. And you can require weld charts or weld maps. So to finish up, if you want to ensure that the production welding done on castings meets your quality requirements, the most important thing is to make sure that the casting suppliers you have the integrity of their quality system, the integrity of their business practices, the integrity of their non-destructive testing. All of those things are fundamental. There is no specification, even if you forbid welding, that will keep some supplier without integrity from shipping you products that don't meet your requirement. If you're really interested and you're concerned about the welding because it's a critical component or because you're worried about the quality processes in the foundry, it's relatively easy to go in and check their welding program and audit their procedure qualification records, their weld procedure specifications, and their welder qualification test record. Those are all required by ASTM 488. Any foundry, as long as you order to a commercial grade, they should have that already. If you have your own special alloy, they may not have a pre-qualified procedure, and you'd have to talk with them about the welding and what's allowed and what's not allowed. And if you want them to do the procedure, you're going to have to pay for it because it's a non-standard grade. But certainly the foundry should be willing to develop a procedure and qualify the procedure if you're willing to pay for that so that you have the welding program needed to make the castings you want. If you forbid me from welding the casting, then I'm unlikely to make your castings. One of the common things was in the API standards, the highest level, the highest PSL level, forbade welding. And the only way I know that foundries could do that is they would agree to make 10 parts for you, and the ones that passed without any welding, they'd certify as meeting the high requirement. They'd weld the rest of them, but you were buying all of them, because we really don't have the option of making castings and not being able to finish them to meet your quality standards. And you also need to check and audit the quality system, traceability, and NDT qualifications. That really goes to the business practices, the integrity of the organization, and their technical qualifications. So that's all I had. We have some resources on our website, so you can go to sfsa.org and get these handbook supplements on welding, fabrication welding, and welding of high alloy stuff.
We do have one question that came in. So what's a good metric to gauge whether production welding is overused?
Foundries internally use the pounds of weld rod per ton of material shipped, but that really is an internal metric that depends on the kind of product you're making. And so it can be relatively high if you're making pressure containing parts, and relatively low if you're making simple parts. And so that's the typical metric that people would use, is pounds of weld rod per ton of casting shipped.